Organizations undergoing restructuring often face challenges maintaining access to shared resources when accounts move between AWS organizations. The new Retain Sharing on Account Leave Organization parameter in AWS Resource Access Manager (RAM) addresses this issue. You can configure resource shares to retain access when accounts leave an organization. This allows you to enforce consistent policies using service control policies, preserve access to shared resources during transitions, and treat organization accounts as external accounts requiring explicit invitation acceptance. These capabilities ensure continuity of resource sharing for services like Route 53 resolver rules and transit gateways during organizational changes, without disruption. Organizations managing logs across multiple AWS accounts face challenges in organizing centralized logs effectively. CloudWatch now allows customization of destination log group names when creating centralization rules. You can define name structures using attributes like account ID, region, and organizational metadata. This enables organizing logs into hierarchies matching your operational and compliance needs. The feature is available in all supported regions, and centralizing one copy of logs is free. These improvements help you create more meaningful log structures, easily identify log origins, and manage logs across your organization more efficiently. Monitoring firewall state changes and configuration updates across a network security infrastructure can be challenging. AWS Network Firewall now integrates with Amazon EventBridge to address this issue. You can monitor firewall state changes in real time, receiving alerts for configuration updates. This allows you to create automated workflows for notifications and integrate with ISM and SIEM solutions. By leveraging these capabilities, you can maintain better operational awareness of your network security infrastructure and respond quickly to changes or potential issues. EC2 Image Builder previously required separate lifecycle policies for each recipe, making it challenging to scale as new recipes were added. The new feature addresses this by introducing wildcard pattern support in lifecycle policies and simplifying IAM role creation. You can now use wildcard patterns to manage images from multiple recipes within a single policy, automatically applying to future matching recipes. IAM roles can be created with pre-populated default permissions directly from the console. These enhancements reduce setup time, minimize configuration errors, and enable more efficient management of image lifecycles at scale with reduced operational overhead. ARC Region Switch automates multi-region disaster recovery, but manual steps were still required after failover. The new features address this by automating post-recovery workflows, RDS orchestration, and enabling infrastructure as code management. You can now automate preparation steps after failover, orchestrate RDS database recovery, manage disaster recovery plans with Terraform, and integrate recovery into C/CD pipelines. These capabilities reduce manual effort, minimize errors, and streamline the entire disaster recovery process across AWS accounts and regions. Identifying resource constraints and shard imbalances in OpenSearch clusters previously required manual correlation of metrics and logs, making early issue detection challenging. Amazon OpenSearch service now offers two new cluster insights: suboptimal sharding strategy and cluster overload. These insights help you detect shard imbalances causing uneven workload distribution and identify elevated resource utilization that may lead to request throttling. You can now detect shard imbalances automatically, identify resource overload conditions, receive actionable recommendations for mitigation, and proactively monitor cluster health. These features enable you to optimize query performance, improve resource utilization, and maintain stable cluster operations without additional costs for OpenSearch version 2.17 or later. Amazon Bedrock batch inference previously required model-specific request formats, complicating the process of managing prompts and switching between models. The new Converse API support addresses this by providing a unified, model-agnostic input format for batch workloads. You can now select Converse as the model invocation type when creating a batch inference job, structure your input data using the standard Converse API format, and receive output in the same format. This allows you to use a consistent format for both real-time and batch inference, simplifying prompt management and reducing effort when switching between models. You can configure this new capability through both the Amazon Bedrock console and API, making it accessible and flexible for various workflow integrations.